Hello guys, so today we are going to discuss this problem, trapping rainwater. So this problem was asked in Google interview question. So the problem is something like this, that we are given uh, a array of integers, for example 0, 1, 0, 2 and so on. So this 0 and 1 represents the height of the towers or maybe the buildings, and width of each building is 1. So what will happen is rainwater will fall here and it will get trapped in between the buildings, and we have to find that how much water is trapped after raining. So for example, in this case 0 here represents this one, the first block. So the main point here is, let's not consider this as xy axis. Let's forget it, this one, that this is existent or not. So 0 is here, this one, then 1, so 1 is this one, then we have 0 again, so this means there is no building here. Then we have 2, this one, so this means we have a height of 2 building here. Then we have 1, it means we have 1 here, then 0, it means this one, that is no building, then again 1 this, then we have 3, so it means there is a building of width 1 and height 3. Then we have 2, this one, this building, then 1, then this 2 and this last one. So what can be the maximum water trapped in between the buildings? So if we see here, there, because see, I have told that let's not consider this line. If we do not consider this line, there we cannot trap any water here because there is no boundary here between these two buildings. How much water can be trapped? This is, length is 1, height is 1, so this is 1. Then between these buildings, that is this height 2 and height 3, what can be the maximum water trapped? So maximum water can be that can be trapped is, this is 1, because if we see this is length 1, height is 1. Then this one, this block, if we see here, its length is 2 and height, its height is 2. Please pardon me, it's this one, this is height is 2 and length is 1. So it will be 2, so this was 1 plus 1 and plus 2, it becomes 4. And then this one, this block, if we see, this is length is 1, height is 1, this is 1 again, so this becomes 2 plus 1 plus 1 plus 1, this is 5 in all. And this finally, this one, this, its length is 1 and height is again 1, so this becomes 6. So we have to solve this problem. So blue is the water trapped. So how we are going to solve this problem? Okay, so let us consider this analogy here. So height, the amount of water trapped between the buildings can be considered as the left max minus self height. So what happens here is, let's suppose, let me consider a simple scenario where we have some buildings. So let me consider this is a building of block 1, height 1. This is a building of height 2. Then this is a building again of height 1. So how we are going to calculate in this very basic scenario? Height 1 again, let's take. Okay. So what happens is, when the rain will fall, so water will trapped between here, then it will get trapped here. So what we can think is, if we move from left and we have any building which is of height greater than me, so the present height of this one, the present fill can be the left max. So what happens is that I know that there is a building greater than me, there is a wall, for example this one here, and water will always block there. So if I consider here uh, the left max at this position, this one at this, that is 0 position, we cannot trap any water. Now we come here, that is at 0. So at 0, The water that can be trapped is left max, which is 1 here because its height is 1, minus self height. So self height is 0, so this is 1. And then we move again here on this one. So here we find that this is greater than this, so we can move on this side, because we always have to move from opposite side of a bigger wall, right? So if we come from this side, we cannot trap any water here. Now we are at this index in the array, so now the right max is 1, and what the water can be trapped is right max minus self is 0, right max is 1, and it will be added to the trapped water. So when we reach here, then when two pointers actually cross each other, and then we can quit. So we are going to solve this problem using two pointer approach. So just a second. So this is a code. I'll just explain the code how it goes. So initially we are going to take left, then we are going to take right, which is the right height. So in this case, for example, let me take this one only. This case, this example on the right, let me take this. So I have this block here. Let me just draw it. So this is 2, this is 1, then this is 3. Okay, then we have 1 and 1. Okay, so this is 2, index is 0, then we have 0, index is 1, then we have 1, index is 2, then we have 0. The upper means the height, lower means the index. So this is height, I'll just represent it like this, he. This is 4, then this is 0, this is 5, this is 1, 0, and 1 again, and this is 6, 7, and 8. Okay, so what will happen is we'll start, we'll have left here and we'll have right here. Okay, so we'll go into that part where we'll compare the height of left and height of right. So in this case, the taller building is on the right, is on the left, sorry. So taller building is of height 2 and smaller building is of height 1. So we'll start from right, because we know that whatever buildings will come here, it can be trapped, the water can be trapped here. Let's not consider in between buildings, so we'll start from here. So now in this case, at this position, that is at index 8, there is I'll take two variables, that is the left max, which will be initially, okay, left max, which will be initially 0, and then right max, which will be initially 0 as well. So now at this position, that is at the first iteration, let's say I equal to, or I'll rather say first iteration in this while loop, I'll come here, that is this one else loop will execute, that is the height of left, sorry, this one, the first will execute, the height of left is greater than height of right. So we'll come here, that is now what we'll see at this index, that is at height of right, it means at index here, if this is greater than or equal to right max, so it means my right, that is this building, is greater than 0. Yes, it is. So we'll initialize the right max to 1, that is the height, present height, and we'll decrement it. So now let me just copy it, and right will come here. So now what happens, at this moment we know that there is a building which is greater than this present index, so we can actually trap water in between, and we will take right max, which is at least smaller than the left, this one. So here at this index, we how we'll calculate it, we'll calculate the the water that can be trapped is right max minus height of present. So right max is 1. So what we'll do is out is equal to right max minus present. So it means at this position here at index 7, the water that can be trapped is only 1, right? Then still this condition holds true. Right will again, so now still left, this right max is still 1, and the out becomes also 1. Then we'll move right again to this position. So now in this case we see that uh, right max is still 1. So it means now in this case what happens is we are not going to add anything, because at this position we cannot add anything onto the water, right? So we'll again subtract it, it comes to here, and now again we see that the right max is 1, that is this one is 1, and I am at least smaller than the right max, and there is a wall which is greater than the right max. So here amount of water that can be trapped is 1. So earlier was 1, this is 1, so it will add up and it will become 2. So now in this case right will move to here. So now I find that the left is smaller than right. Now we'll switch on the pointers, because we have to always take a wall which is greater than this one. So now in this case I'll take what left, right? So now in this I'm just deleting this one maybe. So now in this case left max will become 2, uh, and I'll just move left to here. So now at this position I know that the amount of water that can be trapped is the left max, that is 2, minus my height, that is 0, and added with that, so it was already 2. So now the out will be 4. Okay, so now left will move to here, right is already here. Now the interesting case here is, let's see, that height is 1, right? So the amount of water that can be trapped here is this much. This is the box here which I'm just highlighting. It means that the at this one at this index, the amount of water that can be trapped is left max, which is 2, minus my height, which is 1, plus the previous output, so it will become 5. And why so? Because we are actually calculating the amount of water, sorry, this one, we are actually calculating the amount of water that can be trapped at every index. We know there is a wall which is greater than this one. Now it comes here. Okay, so now the amount of water that can be trapped is left max, which is 2, minus my height, that is 0, that is 2 minus 0. And still, because we know this left max is smaller than the wall, the right wall which we have, so it will become 2. So the amount of water that can be trapped is this one and this one, right? So it will become, out will become 7, and now the left and right pointers cross, so we can ignore it. So same analogy is drawn here on this board. So let's see this. So between these two buildings, 2 and 1, the amount of water that can be trapped is this, which is equal to what? Left max, which is 2, minus self height, which is 0. So 2 is the answer. Now amount of water which is trapped above this building is what? Left max, which is 2. So this is left max minus my height, which is 1. So amount is 1. Now what can be the water trapped here? Left max, which is 2, minus my height, which is 0. So this is 2. And why this is happening? Because we have a wall which is greater than every building which is on the left side, and so on. If we consider on the right side, the amount of water that can be trapped here is right max. In this case right max is 1, minus self height, which is 0, and still the right max is 1. We either we consider this or this, so amount of water trapped here is 1. So overall, this way we can calculate the water trapped between the buildings. And what would be the time complexity in this case? The time complexity would be on, because we are using two pointers. One is moving from left, one is moving from right, and whenever these pointers are colliding, we are just exiting the loop. So it will be on traversing only in n. And what will be the space complexity? Space complexity is o1, because we are not using any extra data structure to store the results. And also we are just using these 4 1 2 3 4 5 variables in every case, whether the input array is 5, 50 or 100. So it means the space complexity is always 1, and that's all. So this is the code I have already posted on the LeetCode. So guys, thanks a lot, have a good day, bye.